I'm going to show everybody the three options that they may use in order to fill in a table where they are asked to find a missing quantity in a ratio table where a total is given. Option 1, students may set up a proportion to find the missing values. If we take a look at our table, we know that the slice of cheese pizza plus the slice of pepperoni pizza gives us a grand total of pizza. So I know that 6 plus 15 is 21. To set up my proportion, I am going to use total as either my numerator or denominator. It does not matter. And then I need to choose either if I want to solve for slices of pepperoni or slices of cheese. I will start off and I will try to find the amount for slices of pepperoni. So my ratio is going to be pepperoni over total pizza. So in my numerator, I'm going to put the number of slices of pepperoni, and in my denominator, I'm going to put the total amount of pizza. If I look at row 1, slices of pepperoni pizza, I have an unknown. It's blank. So I'm going to substitute the letter P for pepperoni. And if I look in the total column, I have 7. 7 total pizzas. I will be using this row, and I choose this row because all of my numbers are whole numbers, number 1. And number 2, this is the only row where I know all 3 values. The values that I will use will be the same as my ratio that I've written down, pepperoni to total. So I will write down pepperoni to total. And now I will cross multiply. That's how you solve all proportions, is by cross multiplying. And we get 105 equals 21p. To solve this equation, we divide both sides by the coefficient. 21 divided by 21 is 1. And 105 divided by 21 is 5. Because P stands for pepperoni, I will take this value, substitute it for pepperoni. To find this value, I just take the 7, subtract from that 5, and I get 2. I will do these next two with you. I am given 8 slices of cheese pizza, and I am to find the number of pepperoni pizzas. So I am going to create a ratio of cheese pizza to pepperoni pizza. I could, if I wanted to, make the numerator pepperoni and make the denominator cheese. I could have, for this one, made my ratio cheese to total or total to cheese. It does not matter. I am going to continue to work with this row because all the numbers are whole numbers. There's no fractions. I could use this row. I could, and I would get the same answer. And I will show you, using this row with the next example, how to do this. But for now, I'm going to use 6, 15, and 21 as my values to substitute. My ratio is cheese to pepperoni. So I will put 6 in the numerator, 15 in the denominator. Looking at what I need to solve, I do not know how many pepperoni slices there were, but I do know how many slices of cheese there were, 8. So I will substitute 8 for cheese, and I will substitute the P for pepperoni. Cross multiply. Divide by the coefficient. And there are 20 slices of pepperoni pizza. P stands for pepperoni. Eight plus 20 is 28. Now what we have here is we are given the number of slices of pepperoni pizza, and we are asked to find the number of slices of cheese pizza, and then come up with the total. So for this one, I am going to make my ratio cheese to pepperoni. There is no reason why I chose that. I just wanted to choose a different ratio from what I've chosen in the previous examples. And I just wrote proportion down. It's supposed to be pepperoni. This is my missing value. It's in the cheese column. I have no idea how many slices of cheese there are, so I will write the letter C. The number of slices of pepperoni are 13 3/4. I can use any one of these 3 rows to substitute the values. I've used this row twice. I'm going to show you right now that I can use this row and still get the correct answer. So I have cheese in the numerator, so I am going to put 2 in the numerator. I have pepperoni in the denominator, so I will substitute the 5 and cross multiply. Again, I'm going to use some side arithmetic to come up with 2 times 13 3/4. 4 times 13 plus 3 is 55. So I get 55 fourths. And then I have to cross reduce. And I get 55 over 2. Divide both sides by 5. I'm going to use some more side arithmetic. Keep inverse reciprocal. And I get 11 over 2. So my answer is 5 1/2. So because I have the letter C here, C stands for cheese, I put 5 1/2 in place of cheese. And then I could add these 2 numbers together. I'm just going to do my work down here. Common denominator is 4. And we get 18 5/4. Because this is an improper fraction, this converts to 1 1/4. And when I add those two numbers together, we get 19 1/4. Now when you go to do the proportion method for this one, you would just choose cheese to pepperoni. You could even choose cheese to total as your ratio. And just substitute the missing values and then cross multiply. Option 2 is using an equation. And using an equation is the YouTube video that I sent on Tuesday. I'm going to show just one example with this because I know that students do not care too much for the using of the equation. So I'm just going to show it briefly. The first thing you have to do is find the constant. Now in order to find the constant, you have to take the y value and divide that by the x. This is the dependent variable. This is the independent variable. So blue depends on x. So I would put 5 1/4 in the numerator and 3 1/2 in the denominator. And now I would convert both of these into improper fractions. I get 21/4 divided by 7/2. In order to get 1 in the denominator, I have to divide both the numerator and denominator by 7/2. Any number divided by itself is 1. And then we perform keep, inverse, reciprocal. And I can cross reduce. And I get k to be 3/2. So this means that my equation that I would use for all of these is y equals 3/2 x. Or if you want it to be more specific, blue equals 3/2 yellow. And how did I get that? Blue, or letter B, is in the y column, so I substituted B for y. Yellow, or y, is in the x column, so I substituted y for x. And just to take this one as an example, this is in the B column. I could not substitute this for y or for yellow because this does not represent yellow. This represents blue. So I would take the 6 3/4 and substitute it for B. And I'm going to use this sheet of paper to show you that this is my equation. I'm going to substitute 6 3/4. I'm going to convert the mixed number into an improper fraction. Because my coefficient is a fraction, I need to use the phrase multiplicative inverse. Basically, it's just multiply both sides by the reciprocal. That's just the technical term for it. You can clearly see that the 2's cancel out, the 3's cancel out, so I'm left with y equals. You can see here that 2 divided by 2 is 1, 4 divided by 2 is 2, 3 divided by 3 is 1, and 27 divided by 3 is 9, and I get 9/2, which equals 4 1/2. So I take this value and I substitute it for y. And then I could add these two numbers together and figure out the total. You would not be able to use the equation option for the total. When you are just given the total, we do not have any values to substitute for B or Y. So you would either have to use option 1, which is setting up a proportion, or option 3, which I will talk about in a few minutes. To finish this table off, the 6 1/2 would be substituted for the letter Y, for yellow. And then you would simply take the same equation, substitute the 6 1/2, convert the 6 1/2 into an improper fraction, and multiply. And you would take the 9 3/4, which represents B, find the B column, and substitute the 9 3/4. And then you could add these together to get the total, add these together to get the total, add these together to get the total. Now to get these two, as of right now, I've only discussed option 1, so you could use the setting up a proportion method. For number 3, I am going to show you how to use finding the unit rate. We all know that to find the unit rate, we take the Y value and divide it by the X value. The dependent divided by the independent. In this case, the only dependent and independent variables that were given is this row right here, 3 1/2 and 7. 7 is in the Y column, it goes in the numerator. 3 1/2 is in the X column, it goes in the denominator. In order to get a unit rate, I need to get 1 in the denominator, and the only way to do that is to divide the denominator and numerator by the denominator. I first converted this into an improper fraction, divide the denominator by itself, divide the numerator by 7/2. Any number divided by itself is 1. Keep inverse reciprocal. 7's cancel. I'm left with 2. So what does this tell us? It tells us that for every 2 miles that we biked, we ran 1 mile. It's a 2-to-1 ratio. That's what we just figured out right here. Y is in the numerator. X is in the denominator. So we get our Y is 2, X is 1. Y is 2, X is 1. So it's a 2-to-1 ratio. So if I add these two together, 1 plus 2 is 3. And that's important to know for when we are just given the total amount of exercise. So what I'm going to do is take the total amount of exercise, which is 6, and I can divide this now by 3, and I get 2. This 2 I can then place here. 2 times 2 is 4. And then if you add these two together, you see that 2 plus 4 equals 6. Now, I know a lot of people are wondering, well, Mr. Meeks, why the heck did you divide 6 divided by 3? I did this because in my head, I knew that distance ran was blank. I know that 6 times 1 is 6. And I know that 3 times this, which is R, is 3R. And then I just, in my head, divided 6 by 3 and got 2. So I knew to put the 2 there. 6 times 1. It's kind of like setting up a proportion, except I'm kind of doing it mentally in my head. Because all I thought to myself was, okay, if my total is 6, then I can cross multiply 6 times 1 and get 6. 3 times R is 3R, and I can divide those and get the 2. And I know that my ratio is a 2-to-1 ratio. So if I run 2 miles and it's a 2-to-1 ratio, then I biked 4 miles. If I reduce this, 4 over 2, I get 2. This is a 2-to-1. These are equivalent ratios. And if I were to take a calculator and take 3.5 and multiply it by this 7, multiply it by our unit rate, which is 2, I get 7. This is a 2-to-1 ratio. When I add these together, I get 10.5. I'm going to do the same process here. I know that it's a 2-to-1 ratio, so if I have 5.5, I'm going to divide this by 2. And I get 2 3/4. And just to check my math, just to make sure that I was supposed to divide, this is a 2-to-1 ratio. So if I have 2 3/4, if I multiply this by 2, I should get 5.5 because it's a 2-to-1 ratio. 2 3/4 times 2 is 5.5, which is exactly what I have here. Again, this is a 2-to-1 ratio, so I would take this number and multiply it by 2. So 1/8 is 1.25 as a decimal. So I would take 2.125, multiply it by 2, and I get 4 1/4, 4.25. If I didn't have a calculator and I did not convert this into a decimal, I just would have taken 2 1/8, converted it into a improper fraction, and multiplied it by 2. And cross-reduced. And got 17 over 4, which is equivalent to 4 1/4. Again, this is a 2-to-1 ratio. So what I would have done, or should do, is take the 3 1/3 and divide it by 2. Now I know that this number right here is a repeating decimal of 0.3333333333. So in order to get an accurate answer, I need to convert this into a improper fraction. And I'm going to divide this by 2. And I get 5/3, which reduces to 1 2/3. And then I could add these two numbers together, find a common denominator, and get the total exercise. Same thing with those. So that is the method for option 3, which is finding the unit rate. And you can use either one of these options, whether it's setting up a proportion, whether it is using an equation, or whether it's finding out what the unit rate is, 2-to-1, and then you divide to get this and multiply to get this. either way, either option, you're going to get the right answer. And the only way you're going to get better at this is if you keep practicing these tables. So we are going to keep practicing these tables on Friday and on Monday. And hopefully by then, everybody will have a clear understanding of how to do this. If not, you can always see me for extra help.